This method does not require a set of simultaneous equations to develop nth order polynomial. Can you guys hear me very well?
Yes,
Yes, sir.
So the nth order. So this is another technique. Yes. The nth order polynomial nth order interpolation formula as the form you remember the last time when we were doing Lagrange formula interpolation, we had a different technique. Okay, so this is a Gregory as a different technique. So generally you have a formula that starts with A1, A2. We will define what it is in a while. Okay, you're not required to remember all these things. This is just a tradition to give you the general formula, form of the polynomial. When we do an example, things become very clear. Okay, this is the form Gregory-Newton interpolation formula, where X is the independent variable. AI for I is equals to 1, 2, n plus 1 are the unknown coefficients. And then you know from the last time, all those x1, x2, x3, and stuff, they are just like x1, x2, x3, and so forth, and not like fx1, fx2. Like these are the data sets. Are the data points. So these are the data points usually given to you. And then you use the above formula, the Gregory-Newton formula, interpolation formula to come up with a polynomial. Any question? Okay. For xi, for data, you will get fxi. Okay. So the rest are just a little bit more writing to do, but just for formality's sake, the n+1 coefficients can be evaluated. These are just a reading part of it. What I'm writing here, I'm going to do it as an example later. Okay, then you'll see. So the n+1 coefficients can be evaluated from the set of n+1 values of the dependent variables. Assuming the n+1, that the n+1 values of the independent variables are placed in ascending order. That is, it's just simple things written in a difficult way. Okay, so let's say if I want to compute using this formula, compute A1. To compute A1, all we have to do, this is the A1 we are talking about. Let's say A1. If you want to find out what that is, all you have to do is set in this equation. When I set x equal to x1, see what happens. If I replace this x here with x1 and all the x's here with x1, so what will happen here? If I replace all the with x1, it's x1. So you can see x minus x1 is 0, right? Right or not? So this is going to 0. All this will go to 0. You just write this. Then maybe you're confused. Are you guys with me?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
A1. Yeah, okay. A1 plus A2 x1 minus x1 plus A3 x1 minus x1. Then you have x1 minus x2 plus A4 x1 minus x1, x1 minus x2, x1 minus x3, plus it goes on. Okay, but you don't have to go very far because you can see from here x1 minus x1 is 0, right? Okay, similarly here also x1 minus x1 is 0. So all other terms they're going to have x1 minus x1. So what's going to happen is all those terms after the A1 is going to go to 0. This will be 0, all 0. You know, this one is 0, then plus, you know, it's going to be all 0. 0. Okay, so in that case, what I'm going to get here, my A1 is simply, okay, I forgot something here. I'm supposed to put x1 here. Okay, so let me do that. Okay, so I have x1. So now we can say that A1 is simply fx1. So you have found the coefficient A1. Any confusion? Any?
No, sir.
No, sir.
Is it clear?
Yeah, clear.
Yes,
Very
sir.
clear, sir.
Okay. Next, find A2. To find A2, set x equals to x2. Same thing, like what you did above. You go ahead and evaluate fx2. So same as like what you did, you're going to now substitute all the x with x2. Okay, so you're going to have A1 plus A1, A2, x2 minus x1 plus A3, x2 minus x1. You're going to have x1. Okay, forgot the 1 here. Okay. x2 minus x1, and then x2 minus x2. And then plus A3 So A4, then go to x2 minus x1, and then you're going to have x2 minus x2. Then you're going to have x2 minus x3 plus so on. Now again, you can see some terms here will go to 0 because wherever there's x2 minus x2, this is going to 0, right? So wherever there's x2 minus x2, it's going to be 0. So if you continue with this equation, all the rest after the A2 is going to go to 0. Everything after this is going to go to 0. So in that case, what are you going to get? So you're going to just get this part here. Fx2 is A1 plus A2 x2 minus x1. Okay. So from here, A2 is going to be fx2 minus A1 divided by x2 minus x1. Let's put it here. See, given the data set x1, x2, now from before, you know, you can find A1 if x1 is given. X1 is given. So fx1 is known. And therefore, you can find A1. So from here, you can find A1. So from the second equation, so you know A1 can be found before. Similarly, you can find fx2. If x2 is given, if x1, x2, all this given, therefore you should be able to find A2. Next, to find A3, set therefore fx3 becomes, so just same formula as before. Then you just, what you need to do, you set the x equal to x3, then you're going to get A1 plus A2 x3 minus x1 plus A3 x3 minus x1 A4 x3 minus x1 So, you know, like you can see now, this part here going to 0. So anything after this also is going to 0. So now you can solve for A3. So now you can find A3. Everything is known. Once the data is given, you know everything. You know A1 and A2 from your previous calculation. X3, all these data points are given. So A3 can be found. A3, A1, A2, A3 are coefficients. Once you have the coefficient, then only you can find the polynomial. Because polynomial has coefficient. This process can be repeated to find A4, A5, A6, and the rest. So when more coefficients are involved, the calculations will get quite lengthy and tedious. This is where programming comes in. People do numerical analysis, usually use programs like MATLAB, MathCAD, or they also can write their own program if the problem is complicated. Now let's do a quick example. Okay, you guys follow this. Is everybody online?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
Okay, thank you for your response. Example. Given data 1, 2, and 3. For x is 1, when x equal to 1, fx is 1. When x is equal to 2, fx is 8. When x equal to 3, fx is 27. So this is like x1, x2, x3. Like what's inside here is fx1, fx2, fx3. So given this, you want to find the polynomial. The first thing you want to do is to find the coefficients. So we have all this formula, right, for the coefficients. We have this formula to find A1. I mean, in this case, it's already there. Why go and derive this again, right? It's already there, so let's use it. So A1 is equals to fx1. And what is fx1? This is not very clear here. This is fx1, fx2, fx3. fx1 is equal to 1. Any problem with that? A2, go ahead and use this formula. We have this formula here. Since you guys know I'm lazy, right? So usually just copy and paste. Maybe you should get a iPad. That way you don't have to write very much. Using this formula, fx2 is given 8. A1 is 1, divided by x2, 2. x1 is 1. 8 minus 1 is 7. 2 minus 1 is 1. So A2 is 7. Similarly, A3 can be found using that formula. Okay, let me copy and paste, tedious formula. So that's why we want to use programming. In programming, when things become tedious, let the program do all these tedious involving computation. Using this formula, just plug and chug. (27) minus 1 minus 7. Okay, that's it. Then now what you need to do, okay, since you are only given 3 set of data, so we only can find up to A3. So you can find A1, A2, and A3. Next, we use the formula. Fx is A1, this formula here. This formula, why should I write it again when it's here? It's the same formula. What do you need to do? Now it's not x1 anymore, it's just fx. Because right now this is a general formula. We already know, we already found all that we need. We already found A1, you have found A2, you have found x1, you have found x1, A3, and x2. x2, x1 is not found, it's given. But you found the coefficients. You found all the coefficients, A1, A2, and A3. The rest are given. Then you just plug in those numbers, whatever information that you have got. A1 is 1. A2, 7. Okay, that's it. That's what you want. That's the answer. Any question?
No, sir.
Okay.
No, sir.
Okay, now you already found the
Okay.
polynomial using Gregory-Newton. Formula. Let's say now these are the data set given to you. These are the data set given to you. Let's say if I now ask you to find what will be fx from this polynomial here, I'm asking you to find, for example, x, given x is 2.2, find compute fx. Okay, that's quite easy. All you have to do, you just have to plug in x is 2.2 in this equation. F 2.2, 2.2 minus 1, will give you around 10.84. So now you see the polynomial helps you to find values for x when it's not given here. You know, you can, once you find a polynomial, then you also can find fx values for data that's in between 1, 2, and 3. Maybe you might not be able to find something greater than 4, 3, because this polynomial is only fit through this data. So the numbers that you're trying to find, it has to be below 3, 1 to 3, somewhere between 1 to 3. I think that will give you more accurate result. If you want to find values greater than 3, then you must have more data. You know, this polynomial here, actually you don't have to simplify. But if you want to simplify, you don't really have to simplify. But you know, if you want to simplify, you just have to multiply them out, simplify, and put them into power form. Now this is in a Gregory-Newton form. We can change this into power form if you multiply them, foil it. You know, when you do all this and then you add them up, finally you will get something like, I don't know, this is accurate or not, 6x squared plus minus 11x plus 6. This is power form. Okay, that's all for Gregory-Newton.